All right, you guys. So I know that you love to factor, so we're going to learn a lot of ways to factor in this section, which some of them you'll probably have seen before in your previous math classes, but there's actually a lot of new factoring techniques that you had no idea about, and I know you're dying to learn about them. So let's get going. Okay, so these that I have sorted here are ones that you have probably seen in previous sections or previous math classes. Okay, now, first of all, something is called a prime polynomial if a polynomial cannot be factored. So if you try all the factoring techniques that we're going to talk about and none of them work, it is called prime, which means it just can't be factored. Okay, so the first one we're going to talk about is a difference of two squares, which the reason why I have it split up into terms, you guys, is we are going to identify which factoring technique to use based on how many terms your polynomial has. That will help us to figure out which technique to use at which time. Okay, so a difference of squares. What this means, if you have two numbers that are perfect squares, so I'm going to slide back here. So see this a squared and this c squared. Now, perfect squares are things where you can multiply something to itself and get a number. So things like 4, 9, 16, etc. are perfect squares. So we have to keep in mind perfect squares in order to use this. So you can only use this formula if you have two perfect squares, so two things where you can basically take the square root of them. And what you're going to do after you figure out that it is a perfect square, okay, it has to have two terms and they have to be subtracting. A difference means they have to be subtracting. So it's two numbers that are subtracting and are perfect squares. Okay, and what you're going to do, you're going to square root each of the pieces, but we're going to ignore the negative. We're not going to include that. And after we square root the first term and the last term, all we do is add and subtract what we get, which the a and the c are the values that we get after we square root the first and last term. So that's what you guys will be doing in these first example problems. So go ahead and pause the video and watch example 1 and 2. Alright, now the next technique we're going to talk about is called general factoring, and the way I'm going to teach it to you guys is by slide and divide. Now if you see here, all of these, how many terms do they have? They all have 3 terms. Okay, so if you see something that has 3 terms, okay, you're going to be using slide and divide, which is referred to as general factoring. Okay, also another way to do this is through the quadratic formula, but we'll talk about that a little bit later. Okay, so we're going to be talking about how to slide and divide. So you use slide and divide when you have 3 terms, and it's a really cool way to factor. Now, if you've learned factoring techniques and you do not like slide and divide, it is okay, you guys. You do not have to use slide and divide. You can use whatever technique you feel most comfortable with. Okay, so go ahead and pause the video and watch example 3 and 4. All right, for the next problems we're going to talk about, we're going to be talking about the quadratic formula. Okay, which I'm actually going to go back to here. Okay, the next technique, if you have 3 terms, if you hate factoring, you're like, I loathe it, which I don't know why you'd hate factoring because it's awesome. But if you do not like to factor, something that works every single time is the quadratic formula. And sometimes, you guys, we won't be able to factor using slide and divide when we have 3 terms. Sometimes factoring will fail us and we cannot use slide and divide. So the quadratic formula will save us. Now, something to keep in mind, if you ever use the quadratic formula, what you're actually doing is finding the zeros or the x-intercepts or the roots of the polynomial, which these are not factors. To get your answers from the quadratic formula in factored form, you have to move the a to the other side and the b to the other side. Or basically, you guys just do the opposite sign. So this down here is factored form. Okay, factored form requires things to be multiplied together, which the x minus a and the x minus b are 2 parentheses that are multiplied together. Okay, and the way that we get x minus a and x minus b, you guys, you change the sign of what you get when you use the quadratic formula. So if you get a positive number in here, it will be negative. That's why it's x minus a. Alright, and if you have a negative number in here, it will be positive. So if this would have been like a negative b, in your parentheses, you change the sign and turn it to a positive b. Now, I'm going to switch gears real quickly, and I'm going to go to our quadratic formula Prezi because I have those on a separate Prezi. Okay, so let me get that set up. Quadratic formula. All right, sorry guys, I should have already had this pulled up. That's my bad. Come on, Prezi, go, go. Go, Prezi, go. There we go. All right, so the quadratic formula. This is something that works every single time, and again, it works every single time, and sometimes when factoring fails us, we have to use the quadratic formula. So sometimes it is a necessity. It is necessary to use the quadratic formula at times. All right, so this is a quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which, if you haven't heard my nifty song, I am going to teach you a nifty song to learn the quadratic formula because it is kind of long. Okay, now, where all these things come from, you guys, the b, the a, and the c, those come from a standard form of a polynomial or a quadratic, which is ax squared plus bx plus c. Okay, and the a's in the formula come from the number in front of the x squared. The b comes in front of the x, so whatever's in front of the x is the b, and the c is the number off by itself. Now, the reason why I call this the opposite of b, not negative b. Okay, if my b was positive, I'd put a positive in for the b. So if, say, b was like 2, okay, I'd put a 2 in for the b, and it'd be negative 2, which is the opposite of positive 2. Okay, and say I had a negative number here. So say I had like negative 4, and I put it where my b was. So it would be negative 4, and a double negative will turn positive. So that's why I like to call this term the opposite of b. That way you don't even have to go through that process. You just take b and you make it the opposite. Now, one more tidbit before we keep going. When we use the quadratic formula, your equation must equal 0. It has to. If it does not equal 0, you have to move everything over to one side to make it equal 0. Okay, so the first two example problems we see here, you will get 2 real roots. So we will have 2 solutions. Now, one of them is going to be rational, which means it can be represented as a fraction. And one of them will be irrational, which means it'll have some square root that cannot be simplified, that won't be a perfect square. And if you wrote it in decimal form, it would have some long, ugly, gross decimal. But don't worry, you guys, we won't write it in decimal form because decimals are the devil. Okay, so we're going to keep it in square root form, so don't you worry. All right, let's go ahead and pause the video, and these will be examples. Let's see, I'm trying to think back. Examples 5 and 6. Or no, examples 5, A, and B. Okay, so go ahead and pause the video and watch the next example problems, which I'm pretty sure are example 5, A, and B. All right, now, these 2 example problems. Okay, something weird is going to happen with these. Okay, so when we do these, okay, you are going to get some weird answers. Okay, in the first one, you are going to get something called a double root, which is when you get the same answer twice. Okay, which that means it will have one solution because you'll get the same number twice. So it only has one answer. But be careful. Double roots, you guys, count as 2 separate zeros. So you'll get 2 real zeros, but you only have one solution because you'll have the same answer twice. Now, in the second one, you're going to get 2 imaginary roots. So you're going to be looking at the value of I, okay, which remember from the simplifying radical videos that you guys watched, which actually that was example 5. These back here, now that I think about it, are 6, A and B. I apologize. This one will be example 7 and 8. Okay, but you have to think back to the example 5 video when I taught you how to simplify radicals. And if you have a negative underneath a radical, okay, an I will pop out. Okay, so there will be some example problems that involve simplifying radicals that I forgot to mention. Okay, well that will be all that we're going to talk about on the quadratic formula. So let's keep going. Okay, we talked about that. We talked about that. All right, so we have talked about difference of 2 squares, general factoring, which is slide and divide, and the quadratic formula. Now we're going to learn about some new factoring techniques that you probably have never seen before. It's going to be awesome, you guys. So one of them is a difference of 2 squares. I'm sorry, difference of 2 cubes. One of them is a sum of 2 cubes, and one of them will be called group factoring. So The next factoring technique we're going to talk about is factoring by grouping or group factoring. Now, if you look at these look very intimidating, but I promise you guys they're not as scary as they look. So if you look here, these contain 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So if we go back to the table, you guys, okay, if you have 4 or more terms, the only option is to do group factoring. Okay, so on the group factoring problem, sorry, not that one. Okay, these we know we have to use group factoring because we have 4 or more terms. So you can go ahead and pause the video and watch examples problems 9, 10, and 11 and learn how to group factor. It's going to be awesome, you guys. Alright, so we've talked about group factoring. Okay, now the next new technique we're going to talk about is a difference of 2 cubes, which it kind of sounds like a difference of 2 squares. Okay, so first of all, in order to use a difference of 2 cubes, you have to have 2 numbers that are subtracting, which if you see here, we have the a cubed minus the c cubed, and they have to be perfect cubes, you guys. So what a perfect cube is, that means we need a number where you can multiply something to itself 3 times and get that number. So for example, a perfect cube could be like 8, because 2 times 2 is 4, times 2 is 8. Another one is, let's see here, 27. Okay, because 3 times 3 is 9, times 3 is 27. Okay, so in order for them to be a perfect cube, you have to find a number that will multiply to itself 3 times and get that number. So if you see anything like that and they are subtracting and there are 2 of them, you're going to be using a difference of 2 cubes, which is the process we use when we do a difference of 2 cubes, you guys. To get our answer, to get our a and our c, we're going to have to cube root the a cubed and cube root the c cubed. That will give us our a and our c, and after that, you guys just substitute that bad boy into the formula, and then you'll be done. Okay, which I did not mean to do that. Sorry, guys. Alright, so in both of these, if you see here, they're both subtracting, and there's 2 terms, and eventually, which some of them you cannot cube root yet, but after we do some GCF factoring, you will be able to cube root. So go ahead and pause the video and watch example problems 12 and 13. Alright, now the next factoring technique we're going to talk about, and the final brand new factoring technique we'll talk about, is a sum of 2 cubes. So a sum means we're going to add, and 2 cubes means we need 2 numbers, so these are going to have 2 terms, you guys. We're going to have 2 numbers that are perfect cubes, so you can multiply something to itself 3 times and get this number. So if you spot anything like that, again, it's very similar to a difference of 2 cubes. Okay, we are going to be cube rooting the first term, cube rooting the second term, and then that will be our a and our c term, and then you just substitute that bad boy into the formula. Then you'll be done. It's going to be awesome, you guys. So go ahead and pause the video and watch example problem 14. Okay, so we have talked about all of these different kinds of factoring techniques, which they have all been amazing. Okay, so this chart is going to be really helpful, you guys, because it tells you what technique to use based on how many terms you have. Okay, and that's going to be very important because they all kind of get jumbled up in our head because there are a bunch of different factoring techniques. So if we can at least narrow it down to how many terms it has, that will help us to find the factoring technique. So I know that you guys have been dying to use all the factoring techniques that we have talked about so far. Okay, so these next 2 problems, we're going to be combining all the factoring techniques. So this chart is going to come in handy because we have to know which factoring technique to use at what time because we're combining all of them. Okay, so go ahead and pause the video and watch example problem 15. Example problem 16 is also going to combine all the factoring techniques we talked about. So again, if you think about the chart, it's going to help you to decide how to start off factoring, and then you have to keep asking yourself, can I keep factoring? And you just keep factoring until you can't factor anymore. It's going to be exciting, you guys. So go ahead and pause the video and watch example problem 16. Alright, so the last thing we're going to talk about in this section is something called the factor theorem. Okay, which the factor theorem, let's think about it. What does it mean for something to be a factor? Okay, so if I asked you, like, what are the factors of 20? Okay, think about what those would be. Okay, you're probably thinking like, well, 2 times 10 is a fact. Those are factors of 20. 1 times 20, 4 times 5. Okay, factors, you guys, are things that multiply to equal something. And if you take factors and divide them into their original number, you should not get a remainder. Like if we think about the 20 example, 2 factors of 20 are 2 and 10. So if I divide 2 into 20, you get 10, and you don't have any remainder, you guys, because it divides evenly. Okay, so factors will always divide evenly into a number, which means the remainder will always be 0. So all this says is the divisor is a factor. So this is talking about polynomials now, you guys. So if we divide something into a polynomial, which that's a divisor if you think back 2 sections, okay, if you divide something into a polynomial either through long division or synthetic division and you get a remainder of 0, that divisor will then be a factor, which this is the factor theorem. Holy hot dog, right? Alright, so in example problems 17 and 18, what you'll be doing, okay, first of all, I have 2 divisors here for you, and what you guys will do through either synthetic or long division, you will determine if the divisors are a factor, which they are a factor, if after you divide you get a remainder of 0. And once you have simplified it down using the quotient, which is also called the depressed equation, because the depressed equation is small and sad and depressed, unfortunately. But the quotient, using the quotient, what we're going to do is we're going to find the remaining factors. So with the quotient, we're going to ask ourselves, can we keep factoring? And using the quotient, we should be able to find the remaining factors using some of the factoring techniques I taught you using the nifty chart. Oops, went too far. So after we determine if the divisor is a factor, using the quotient, we'll ask ourselves, can we keep factoring? And we'll reference this chart to see which factoring technique would be helpful when we factor. Okay? Alright, so go ahead and pause the video and watch example problems 17 and 18. And all we have left is an epic funsy, which you'll have to wait till class to do that funsy. Alright guys, I had so much fun.